in this video, I am resuming your Laws of Exponents lesson. We are going to pick up with numbers 21 and 22 in Delta Math, which are we-do problems. I am picking up using the same handout that I created. If you were capable of printing, I hope you were able to do that. If not, that's okay. Just note that all problems should be written in your notebooks, and you should be submitting them along with work and answers in along with your notes. Okay. So for today, you're welcome to use the worksheet or make sure you put it in your notebook, but we've got to complete all these problems in Delta Math. There are 36 problems we've already done. You should already have completed 1 through 20 in Delta Math by now. So we're going to pick back up, guys. We actually are not introducing the next property just yet. We're going to finish 21 through 24, which are 21 through 24 focus again on the power property, because I see a power on the outside of a set of parentheses. Recall from the notes in the prior video that anything raised to a power means the inside that many times being multiplied together. So what this really means is negative 3xy to the fifth 3 times. That's what that means, okay? When I type in negative 3 to the third power, I should be careful to make sure that any negative number, when I type it in, I put parentheses around that negative number. So whether you type it in your calculator or you recognize that negative 3 times negative 3 is 9, and 9 times negative 3 is negative 27, that we are not doing negative 3 times 3. It will never be that, okay? Do not do, oh, this is negative 3 times 3, which is the power, and get negative 9. That is completely wrong, okay? Don't do that. So if you remember what it means the inside 3 times. So again, negative 3 times negative 3 times negative 3. Remember that if you don't see an exponent, it's understood to be 1. And remember your power property. How do we make numbers bigger, quicker? What math is more powerful in terms of making numbers bigger, quicker? Multiplication. So that means I multiply these exponents, and I will have x to the 1 times 3 is 3. Y to the 5 times 3 is 15. Or if you were to think about expanding it out, it means how many x's am I multiplying together? You can see right here I have x and x and x, which is x to the third. And I have 5 y's and 5 y's and 5 y's, which make a total of 15 y's. So applying your property can be quicker, but if writing it out helps you to better understand it, then you're more than welcome to do so. Over here for 22, it means the inside. So again, hit pause if I'm going too fast, because I am going to assume that you know to just hit pause and write it down and then resume the video. So this means the inside 4 times. So this means, and one way to think about it is understand there's an understood exponent of 1 even for the number. So this is 5 to the 4th power, x to the 3 times 4, and y to the understood 1 times 4. So I'm illustrating it kind of differently than this, but it does mean you can also write it 4 times. But if you're doing it in your head, this is probably what you're doing. So 5 to the 4th power means 5 times 5 times 5 times 5. So I'm just going to write that out. 5 times 5 times 5 times 5. Use your calculator if you like to either type that or to type in 5 to the 4th power. 5 times 5 is 25 times another 25. That's a big number. 25 times 25. When I can't forget it and I don't have my calculator handy, and I don't, I'm going to just do 25 times 25. And we get 625. So 625, x to the 12th, y to the 4th, because again, we're just doing what? Multiplying those exponents. So I'm going to type these into Delta Math and then expect you to go and type them in also, but also do 23 and 24. So you do have to type in the problems that I do, and that's part of practicing, making sure we know how to type things in Delta Math too. So that was a negative 27, x to the third, down arrow, y to the 4th. Excuse me. Oh, what did I do? Oh, I just typed in my exponent wrong, didn't I? Luckily, we give you multiple tries to type it in. So again, that was negative 27 x to the third, right arrow, y to the 15th. Yep. So if you haven't noticed by now when we practice, we do set it at like 5 attempts so that you can be clear about, like, if you get it wrong, you can maybe go to examples or watch a video or just look back over your work. So for 22, that was 625 x to the 12th. So I'm hitting shift 6 to make it go up, and then the right arrow to make it go back down to type in the second variable. All right, and again, they're illustrating here that you raise the number to the power to the power, which means you multiply exponents, and you do that for both variables. All right, now we're going to transition because I split up the problems pretty evenly there, and now we have some different problems. So I'm going to ask you to go back in your notebooks. I'm going to a new page in my notes, and we're going to add on the quotient property and negative exponent property. So back in your notebooks. Some ducks going by in my house. So the quotient property, if you think about where the word quotient comes from, remembering that if you are finding a sum, and you should remember this from yesterday, if you're finding a sum, that means you're adding. If you're finding a product, that means you're multiplying. If you're finding a difference, by the way, just as a review, that means you are subtracting. If you are finding a quotient, that means you are dividing. So the quotient property has to do with dividing like bases. So if I am dividing a to the m by a to the n power, I am going to subtract the exponents. So what things I want you to remember are that multiplying and adding go together, and subtracting and dividing go together. In fact, if you take this division bar, which by the way has a name, I'm kind of famous for finding out weird names for symbols. This is not just called a dividing bar, but it's an obelus. The Latins had all kinds of words, or Latin language has words to represent everything, even symbols. So this division symbol is called an obelus. But what happens if you take the dots and you remove them? I'm left with a subtract sign. So when you see a fraction bar, which by the way, a fraction bar, guess what that fraction bar is also known as? We've seen this word before for a repeating bar, right? So this fraction bar is also known as a vinculum. That putting the two dots with it means this whole division symbol is an obelus, okay? And a vinculum is not just a repeating bar, but it's also a fraction bar. Learn new stuff. You never know when you're going to end up on Jeopardy. So again, when I am dividing, I'm going to subtract the exponents. So for example, if I have x to the 5th power divided by x to the 3rd power, this is going to be equal to x to the 5 subtract 3, the top minus the bottom. But there's kind of a trick to this that I'm going to teach you in a minute. Well, if I subtract 5 minus 3, then I'm going to end up with x squared. In expanded form, this means I am multiplying 5 x's on top by 3 x's on the bottom. This is what it means. I always like understanding what things mean, so then if I forget the rule, I still know what it means. So what can I do? What do we know to be true? Just like we know 2 divided by 2 to equal 1, the rule is that anything divided by itself equals 1. So that means that would cancel out because they equal 1. 1, 1, 1, and what's left? X squared on top. Well, what if I switch that up and I'm going to use a this time, but a to the 3rd on top and a to the 5th on the bottom. Interesting. Well, if I were to apply this rule of a to the 3rd minus the 5, Oh, wow. 3 minus 5 is actually a negative 2. That means we need to know our negative exponent property. But if we think about what this means in expanded form, then this means I am multiplying 3a's on top and 5a's on the bottom. And what do we know to be true? Anything divided by itself equals 1. So if I eliminate what is alike, that means I have a squared, but where is it? It's on the bottom. And if it's on the bottom, then I have to have something as a placeholder up top. And what did a divided by a equal? 1. So this leads into our negative exponent property. So understand that if your exponent is larger on top, then when you simplify, your variable will be on top and it will be positive. If you simplify but it's larger on the bottom, I like to think about it this way, where they eliminate and I just subtract the larger minus the smaller and keep it on the bottom. Technically, when we subtract using our rule, though, we get a to the negative 2. This is not incorrect. It's just going to lead us into this, okay? So what I want you to remember is, yes, you are going to subtract, but leave the variable where the exponent is largest. So remember, if I'm writing it on paper, it should be in your notes. Then you subtract. Okay, leave your variable where the exponent is largest, then subtract. And you're going to see how this applies with these examples. But before I get more into the negative exponent property, I'm going to go ahead with, do I want to do, yeah, I'm just going to go ahead and pick back up here with the problems in Delta Math, and then we'll add in the negative exponent property, okay? Let's absorb all this and let it sink in good. So pause the video and write these down if you need to. These are, again, the problems in your Delta Math assignment. For 25, we are first going to simplify any numbers. Well, if we take a look at this, I only have an 8, and I only have it on top, a number on top, so I'm just going to leave my 8 on top. And then I want you to think about what this means. I just got done saying that if we have a common variable, leave it wherever it's larger. So do you see how you have x to the 4th on top and x to the 7th on the bottom? My 7, exponent of 7 is large on the bottom, so I'm going to leave x on the bottom, and then I'm going to subtract and do the 7 minus 4. And then for the y's, it's also bigger on the bottom, so I'm going to do the 4 minus 3. Now I'm showing you this, but this isn't necessarily what I expect to see every time you do problems in the future. So this means our answer, when simplified, would be 8 over, because there's no variable left on top, x to the, what is 7 minus 4? It is 3. And y to the 4 minus 3 is an understood 1. Now why does that work? Because this really means 8, 4 x's, and 3 y's. Think about what things mean in expanded form, and even when you forget your rule, you'll be able to do it, okay? I'm not saying you have to do this every time, but I do find that some students, they don't like the rules, but if they expand it out, they always get it right. So whatever works for you guys. So I'm going to cancel what they have in common. So an x, an x, an x, and an x, and that leaves me with what? 3 x's on the bottom, just like we got in our answer. If I cancel the y's that they have in common, that leaves me with 1 y on the bottom. So see how that works? So that'll be 8 over x cubed y. And we read that as anything to the second power we read is squared, and anything to the third power we read is cubed. After that, we just say to the 4th power, to the 5th power. So that's our answer for 25, applying the quotient property. Now for this, 12 over 18, I'm actually going to grab my phone. I don't think I have it here. Hold on. I'll grab my phone. Just a moment. Just kidding. I don't know where I set my phone. So I'm just going to reduce 12 over 18 using, now remember you can just type in 12 divided by 18 and then hit the math button and then it'll say fraction and you hit enter. I don't know where I set it. But 12 over 18, we can also reduce it using a common denominator. Some students like to go, oh, well, I can use 4 because they're, or excuse me, not 4, but 3, because they're both divisible by 3. If you don't see that right away, at least say, oh, they're both even. If I divide both of these by 2, because they're even, then I get 6 over 9. And then you can go, oh, they're divisible by 3. I'm just showing you this. Most students can do this in their head. But just in case you have trouble with that. So that's going to be 2 on top and 3 on the bottom. But again, you can use your calculator, 12 over 18, and hit math, enter, enter. Or just hit that, tap the math and then the fraction button, hit enter. And then where's exponent for x larger? Oh, they're the same. So if they're the same, when I subtract 2 and 2, I get 0. That means it's gone. Okay, both my x's would cancel out. Now where's my y larger? It is larger on the top. So if I expand out 5 y's on the top and 3 on the bottom, 3 are going to cancel, leaving 2 up top. Or the same thing as y to the 5 minus 3. But if you have trouble with this, again, they're going to illustrate it a couple different ways in Delta Math. So let's talk about how we type in fractions in Delta Math. So I'm going to leave this handy over here so you can see it. I'm going to go to number 25 right here, this we do problem. And we want our answer to be in a fraction. So one thing we can do is beside the shift key on the right side of your keyboard, do you see where the question mark is? Normally to get a question mark, we would hit shift, then that button. But if you just hit that button, you're going to immediately be given a fraction. So I'm going to type 8 on the bottom, then the down arrow, and type in x, shift 6 for the third power, hit my right arrow, and hit y. So again, just to explain all that again, if you look at your keyboard, on the right side where the question mark is, hit the question mark button. That's going to immediately give you a fraction. And up top, you can type in 8, hit the down arrow, then x, shift 6 to do your exponent of 3. Hit the right arrow on your keypad, the right, left, up, down, and then press Y. And then I'm going to submit. And notice they're doing in a similar form, 8 over 1. There's an understood 1 down here. And they've, let's see what they did here. They made it x to the 4th. I wouldn't split it up. I would not necessarily do it that way. So I think the way I showed you on paper is probably a little bit better. But what they're showing you is that 4 x's would cancel out, leaving the x cubed on the bottom. That's what they're showing you. 4 x's will cancel out, leaving the x on the bottom. All right, and then next, for 26, same thing. I have a fraction answer, so I'm going to press it, click in here, and then press that question mark button. 2y, shift 6, so 2y to the second power. Then I'm hitting the down arrow. Actually, going to hit the down arrow or the right arrow to make it go back down. And I'm going to hit the down arrow again to get to the denominator of my fraction and submit. All right. And that's how we do those. So if you'd like to pause and then go ahead and do 27 and 28, that would be great because then I'm going to pick up with some notes on negative exponent properties. So assuming that you've already done 27 and 28 to practice in your notebooks and then typed them in Delta Math. If you notice for 29 through 34 now, 29 has some negative exponents, which we have not yet talked about. You might remember that from Math 1. But then you may also notice, I also have problems that look like 25 through 28, but I have negative powers now. So let's learn how to deal with negative exponents using our negative exponent property. So back to your notes that you were just taking under Quotient Property. And I now want you to put negative exponent property. All right. Your negative exponent property says that if you have anything to a negative power, so I'm going to put negative n for a number, then it's equal to the same thing as 1 over a to the n. So basically, to make it positive, I'm going to flip it to the bottom of a fraction. So to make a negative exponent property, or exponent positive, move it to the opposite side of your fraction, or opposite side of the vinculum. Move it to the opposite side of the fraction. Feel free to pause it. I'm just going to move ahead. So in other words, if I have a to the negative third power, I'm going to draw a fraction bar. And you got to understand that, remember, anything can be written as a ratio. So if I have an understood one here, it's like saying, oh, I'm just going to move it to the bottom and make it positive. But I have to have a placeholder up top, so I put a 1. Oops. Wrote A and I had B in my head, but I meant 2. So what happens if I have x to the negative fourth power over y to the negative third power? Well, guess what? I can move both of them. I can move this one to the bottom and this one to the top. So it's a pretty simple fix. Now, how might that work if I'm simplifying something? If I have x to the fifth power and on top x to the negative third, then I'm just going to keep my x to the fifth, but move this to the top. So usually what you'll see me do on paper is I'll cross it out and I'll write it up top. But that means I have to then apply a different rule. So if I have x to the fifth and x to the third, that's x to the eighth. So our job is to make negative exponents positive. All right, and we're going to apply that by practicing some of these problems. So if you still need to copy something down, hit the pause button. If not, I'm moving on. So I'm going to go, actually, I apologize. Back to your notes. I'm going to add one more thing. If you have a quantity to a negative power, and by the word quantity, I mean something in parentheses. So if I have, say, 2a to the third, and it's to the negative second power, or negative any power, this, if I were to use my power property, means I would have 2 to the negative 2, a to the negative 6. That means they both move. So one of the shortcuts is I can move the whole quantity to the bottom and go ahead and make the 2 on the outside positive. Remembering that, of course, if there's nothing left, I put an understood 1. But then when I evaluate this, it would be 1 over what? Remember what this means. It means the inside 2 times. So 2a to the third times 2a to the third. Or in other words, 2 squared. 2 squared being 2 times 2 is 4. And a to the power property, 6th power. All right? But again, if you wanted to think about it this way, that if you multiplied exponents, that would give you 2 to the negative 2, a to the negative 6, which would then be 2 squared a to the 6th, which again is 1 over 4a to the 6th. So 2 different ways to look at it. I'm trying to show you multiple ways because some people's brains work in rules, and then other people, they want to understand reasoning. And I think that rules can be easily forgotten. They're extremely important, but while we sometimes forget rules, if we know what something means, we'll be able to maintain it long term. So I'm going to move on and do the we-dos with 29 and 30. And then we're going to apply the concept of our quotient and our negative exponent properties to complete this, and then you'll do these. So picking up with 29, again, pause is needed. What I want you to be careful, very careful about here is recognizing that while I'm looking at the problem 4x to the negative 1, only the x is to the negative 1 power. Please keep in mind that if you see a number without a power, it has an understood 1. So do we have a reason to move the 4? We do not. So that means my 4 stays on top, and the x to the negative 1 gets moved to the bottom. And so it's just 4 over x to the first, but of course we don't write x to the first because it's understood, so it would just be 4 over x as our final answer. And I want you to challenge you to keep that in mind. For 31, when you do this, just because you see a negative 2, the negative 2 has an understood power of 1. So we are only moving what? Only the x. Okay? So for 30, notice I have this quantity here to a negative third power, and I just showed you in your notes how to address that. So you can recognize that these have understood powers of 1, which then when you distribute or multiply these exponents gives you negative 3 to the negative third power and x to the negative third power, because I'm multiplying understood 1 times negative 3. And that means I need to move both. So I'm going to move this one to the bottom and this one to the bottom. So when I do that, that means I'm going to have negative 3 to the positive 3 and x to the positive 3. But keep in mind that I have to have a placeholder, so I'm going to put a 1. But we don't leave numbers to a power. Remember what this means. It means negative 3 times. So in other words, negative 3 times negative 3 times negative 3. Or, so you can type it in your calculator like that, or you can type in negative 3 to the third power, like that. But ultimately what that means is you're going to have 9 times negative 3, which is negative 27. So I'm going to have on the bottom negative 27 x to the third with my understood 1 up top. Okay? Now remember the other way to look at that, and you don't have to write both ways, but if you like this method, the other way to think about it, then you write that down. I can just go, oh, that's a negative power, so I'm going to take this whole thing and move it to the bottom and make it positive. So if that helps you to do it better, then by all means do that. They both work the same way. We're still going to get this same result here. For 32, just as a heads up, oh, all of it's to the negative 1 power. So whether you do it where you move the parentheses or you go ahead and use your power property and then move it, note that this is going to be to the positive 1 power. So if you want, you can just go, oh, I'm going to move all this to the bottom. And then it's going to be to understood first power. But remember, when there's nothing left up top, what do we put? A 1. So if you miss this when you do this in Delta Math, remember, you get how many attempts? 5 attempts. So don't sweat it. If you need to, like say if you're like, I don't understand what Miss Robinson is even talking about, what can you do? Well, actually, if I go in student mode, let me do this real quick so it'll look like yours. My apologies. So if I go in here and look at, I'm on 29, you can always go to show example or watch another help video. So watch, if I see 4x to the negative 1 and I'm like, I want to find a problem that looks like that, I'm going to hit show example. Ooh, that looks like that. How did they do that? Right? I can keep hitting next example till I find problems that look like what I'm doing. So pretty cool there. So I'm going to go ahead and type in 4 over x for 29. Again, fraction bar, so I'm going to hit the question mark. And then 4 down arrow x. So the goal is, guys, you cannot leave any exponent negative. You should not be typing any answer in with the negative exponent with these. For the next one, 30, fraction bar, so I'm going to hit that question mark key with a 1 on top and a negative 27. So what if I forget the negative and I just do 27? I'm just pressing enter. It's going to say answer's not correct. Try to find your mistake. You have 4 attempts remaining. And then if you're like, I still need help, you might go, I want to find a negative number and raise it to a negative power. So there's a negative, but it had parentheses, right? So you can keep clicking on next example till you find one. So again, I'm going to look for a negative number with a negative power. See how that can help you? All right. So don't forget if you struggle with this to use that function, okay? And of course, typing that in again, it was 1 over negative 27x to the third. Hopefully you're getting better and faster at typing these in. All right, so the last two I'm going to do, you need to go ahead and complete 31 and 32, so feel free to pause it and complete those. I'm going to move on and do 33 and 34, and then you're going to do 35 and 36 on your own, and then I'll kind of explain what you're going to do the next couple days. All right, so this one here, these are multiple choice, but you only get 2 attempts, okay? And that's because I don't want you going, oh, click wrong, click wrong, click wrong. Yeah, I don't want you to do that, okay? So applying what we learned about negative properties, so look back at your notes, what did I tell you to do? If you have a negative exponent, move it. Just move it. So I want you to take this one and move it to the bottom, and this one on the bottom that's negative and move it to the top. That's it. And then we're just going to simplify it. So that means for now I'm going to keep my x squared and x to the 8th, but that means I'm swapping and going to have y to the 5th and y to the 7th. Y to the 5th on top and y to the 7th on the bottom. So I'm manipulating the problem to make our negative exponents positive. Think back to what we just said though. So go back to up here. All you have to do is think about there being 4 x's on top and 7 on the bottom, and 4 would cancel out, leaving 3 on the bottom. So I am going to subtract, leaving the exponent where it's larger. So remember, right here in your notes, right there, leave your variable where your exponent is largest. When you have 2 of the same base and you're dividing, leave it where it's largest. So here when I compare my exponents, oh, my x is definitely bigger on the bottom, and my y is definitely bigger also on the bottom. Uh-oh, what does that mean I do on top? I put an understood 1. So now let's subtract these exponents. 8 minus 2 is 6. 7 minus 5 is 2. And I'm done. If you still struggle with that, remember that it means you have 2 x's and 5 y's on top. You can see, guys, why we use rules. What if we had like x to the 20th and y to the 30th? We don't want to write out 20 x's and 30 y's. But visually, this can help you to go, oh, I'm going to take out 5 y's and 5 y's, and that leaves me with 6 x's on the bottom and 2 y's on the bottom. And nothing left up top, which means I have to put an understood 1. So if we take a look at 34, what can we move? Oh, I see x to the negative 6. So I'm going to move that to the bottom. Now, where is my exponent for x larger? On the bottom. Where is my exponent for y larger? On the bottom. Then 6 minus 5 is 1. I'm going to leave an understood 1. And 8 minus 3 is 5. But I don't have anything on top, so I have to put an understood 1. If you have something on top, leave it on top. If not, make sure you put an understood 1. So, for this one here, if you notice, guys, you do have, if you compare your x's, think about this. After you move your y's, I'll let you do that. But if you compare your x's is larger on the top. So if you had 6 x's on top and 1 on the bottom, only 1's going to cancel out. Okay? Or just think 6 minus 1 and 5, you have 5 left up top, right? So you will have something on the top here. And for this one here, swap these, okay? And then use your rules. If you need to expand it out, expand it out. So I'm going to assume that you're good at typing this in Delta Math and go ahead and end the video now. So go ahead and type these in and complete 35 and 36 and type those in. Then submit a picture of the notes you took today, which these are my notes I would submit, and it's only 1 page. But when I look at your notes, it should look like mine. It should not be sloppy. I should see, if you want to put the date over here, I should see the titles. I should see every example, everything I've crossed out. Notice I like using sometimes 2 different utensils to write with so that it stands out a little bit. Explanations are extremely important because all of this, guys, if I'm taking a quiz, I'm going to pull all of this out and I'm using it. We're going to use this on a quiz. So if you do not do a good job taking notes, then it's going to hurt you when you take a quiz or a test, okay? So I'm going to end the video here, but with the first announcement that There are no new notes for tomorrow, nor tomorrow you're just going to do Delta Math practice, okay? So you're just going to practice problems using everything that we've taken notes on the past 2 lessons here. And then just note that Monday is Martin Luther King Day, so you are out of school Monday, okay? So just right here, Martin Luther King holiday on Monday, so no virtual day, no school day. There will be no work on Monday, and then Tuesday you'll pick back up, and you will have a quiz on exponents this day, and we're introducing a new topic not related to exponents. So please, please, please make sure if you are having any questions, you let us know. We, of course, teach all this stuff live and answer questions live, so we hope that you will join us during Zoom. But in the case that you don't, you use these video notes. All right, good luck.